Hello, hello. Mic is working. Okay. Hi. Hello. Oh, alaikum assalam wa rahmatullah. Hi. What's up? Morning. Yes. Yes. Hi. Yeah. Good morning or whatever time of day. Oh, hi. I will say alaikum assalam to you as well, which is the answer to salam. Um, uh, yes. Peace be upon everybody. Yeah. Happy Friday. It's Friday. We made it. Um, the last Friday before my freedom ends. Yes, I have continued in my emo phase, but tried to make it as obnoxious as possible. I'm actually testing something with my lick today. Yeah, I think like I'd say the past week I've been like my obsession moves around, but my current obsession is Dracula. So that's why I am in my emo phase. Like that comment stuck with me from yesterday. So yeah, I started listening to the audiobook, and there's the Dracula musical. Wow, hi Oliver, what's up? Hey, hi. Um, I was listening to the Dracula musical showcase on YouTube, which is a Korean musical. Yeah, so I really like Korean musicals. I don't know why. I guess I like the actors in them because like they're either K-pop idols or act like people you see around. Anyway, Interview with a Vampire and read one of Anne Rice's other vampire books. I've seen Interview with a Vampire sometime, but I have not read the books. What do I know about it? I know some information. I heard from a podcast. I don't. Anyway, I know some information. So, what's on the agenda today? What are we learning? This time I'm not gonna trick myself by starting with something fun, because if I do, I won't stop. So I'll start with what I consider difficult, which is here. And ooh, wow, it just ended. I ran all the um, above cells so that we are right where we need to be. And what we did is we have all of the text chunked together, I think. And it's IMDb. So just doing a reminder for myself. Okay. I don't know why I always forget to like ask questions. Like for example, how are you doing today? And stuff like that. What are your plans for today? Stuff like that, you know? And if you're comfortable sharing those things. I did mean to update the mic settings because yesterday I was listening to some parts of yesterday's stream and I was not happy with the mic. So yeah. I'll do something about that later. So all right. Today's lesson is the continuation of the fine-tuning a masked language model, and the processing side is technically done but not really, because I think, yeah, we're around here. We need to tell the tokenizer how do we talk with the tokenizer? We pass the tokenizer to this here, and it masks out a percentage based on the percentage that you give it. All right? Okay. So to see how it works, we feed it a few examples. I did not run this part. I don't know why. I want to make it different. Like, let's say 20%, just so that, I don't know why I also want to write the 0 so I see the 20. Let's see if it makes any difference. If it doesn't, then cool. Yeah. I read a simplified version of Dracula when I was like little, and now I'm reading an abridged version, so I should be proud of myself somehow. 2? Only 2? I tried reading it like a while back, like maybe 10 years ago. I didn't like it for some reason. My data engineering, we're talking about what we're doing right now, or are we talking about a job? Because I don't know what data engineering would mean. It's like being a data scientist, data engineer. I don't know the difference between these things. Is that a good thing or a bad thing? Also, like, different places have like information management people. So like, are these people all the same? I don't know. I work with data. That I can say yes. And if we're talking about what we're doing right now, maybe we're just processing data. So we see mask being spread out. So yeah, now it is randomly masked. Masked. Okay. What's next? So since I ran it. Okay. Anyway. عليكم السلام. هاي. صباح النور. كيف حالك؟ Yeah. Okay. الحمد لله. كلش good. بخير. It's جمعة, so I'm happy. Yeah, I think some Arab places say Jum'ah and some say Jum'ah. I say Jum'ah, which is Friday, basically. Yeah. What's the difference between saying كيف الحال and then كيف? I think كيف الحال could be less like less textbooky, I think. As I said, my Fusha is good. Okay, yo, hi, what's up? Good. How's it going today? I mean, it's just starting, but for now, good. It's good. It's going well. I will try to chill today. Probably will. Yeah, it's a chill day. I want to start strong so that later I can chill with all of my strength. Oh yeah, we looked at the dictionary and we removed the word IDs because it does not want it. So we just gave it examples. Wondering if I am okay. So as a job, I work with data, but I don't have the title of data engineer. Okay, so like I don't feel comfortable calling myself a data scientist at my, I don't know, because it's not my title again. But I am not I no longer would work in software engineering, like software developer. I'm not that. I'm a data person, which I like. It's like working around 5 years in development made me want to move somewhere else. Maybe working another few years in data makes me want to do something else. But I guess this is also working with data, which I like. I really do. I don't know if I show it. Remove it. We did. Got it. So it worked. And the token has been randomly added. These will be the tokens which our model will have to predict. So that this is for training. I added more masks for no reason. For fun. Just to see if it makes any difference. The beauty of the data collator is that it will randomize the mask insertion with every batch, which is fun. I like that. Okay. Try it out. What should we try out? Run the code snippet about several times to see the random masking change. Oh. Happen. Also replace this with convert IDs to tokens to see that sometimes a single token from a given word is masked. A single token from a given... I don't understand what's happening. If I use this, what changes? I'm gonna do both. Tokenizer. Oh. Oh, got it. This is I rented convert IDs to tokens. Oh, what is the scores? Okay. The course is the HuggingFace NLP course, which you might have seen before. HuggingFace has a learn section, and it has an NLP course and other stuff. One of them is vision, meaning images. And I am going through the NLP course. I am at, I guess, unit 7, you can call it, which is the last technically intense unit. The other ones are more like how to ask a question, how to share your demos, and other stuff. So here comes the chat. I put it in the chat in case you're curious. I just put the learn in the chat, not everything. But like, you can go through it, because if you're interested in reinforcement learning, or if you're, I don't even know how using ML in games, I guess for NPCs. Oh. Yep. Usernames can be tricky. Yep. It's not easy choosing one. A single token from a given word is masked and not others. I don't know what it's supposed to mean by that. Single word from a given token is masked and not the others. Like this? Can we see it? No. Yeah, no. Thompson. Okay, whatever. Let's move on. Okay. One side did I move in, zoom in too much? I want to ask about the embeddings. Do you have any good course about it? Embeddings as in like preparing data for models? Embeddings in that way? Are there courses that are like focused on that? I don't have anything in mind, but wouldn't it be like, for example, like this course has a just transformer models. It's an introduction. I guess using transformers is actually a far more detailed one, but it is using, yeah, encoder, decoder, tokenizing, Vtubing, and so on. I don't know if I can help, because in a way I don't really understand the question. Maybe, I don't know, but like if you go to the models section and like look for something word to vec. You can, what are these? What are the tasks of word to vec? Is it just does it do embedding? Can we see like how people worked on it? For example, these are resources, I guess. In a way, I wanted to see if people put resources in their documentation. I guess they do. Okay. So it is the model that prepares. What are embeddings used for? Like, do you visualize it in 3D space? Do you? Yeah. Okay. I am barely remembering. Okay. I know Stanford NLP. I think even word to vec is from Stanford NLP, isn't it? The, what do you call it? Stanford NLP. They are a group. Let's go to their website and see what they have. Okay. Transforming text into vectors. Got it. Resources? Okay. They have a new. Oh, I do want to go to your website. Hello. Okay. So their courses, models? Stanza? They changed their name. They named their, oh. Anyway, resources or training? What is training? Yay, word vectors or something. Okay, but I'm guessing it's, yeah, word vec is theirs. That's for sure. No. Anyway, no. I messed up. Word to vec, I think is metas or something. And maybe glove is theirs? Anyway, do you think this helps? I can send this to you, but if it doesn't, then cool. Yeah. Stanford. Where are their courses? going back little by little. Core NLP. Stanford Language Group. Don't they have a course? Like, oh yeah. In my Stanford. Yeah, no, it's correct. 2024. Wow. I'm too scared to even try this, but I should. Sure. Oh, thanks. Yeah. Yeah. But this is Chris Manning, and I think, look, they have it from 2000. Wow. But like lecture videos from 17 to 23. Yeah. So that book, I want to send that. I don't know if it has what you want, but it should, because it's a textbook. So I'm guessing your knowledge is not like, you don't want as much introductory stuff, but that book is the NLP book. And this course could also be helpful. 2024. Is there anything about yeah, this is what I wanted. Word representation. Glove. See, I remember something about glove, and see, something about word embeddings. Yay. Have I worked with the RAG before? I can say no, definitely no, because it's in the lecture series I was watching, but I haven't used it. I am learning about it. I'm guessing the videos of this is not recorded, so if you want to read the lecture notes, you can do that. Otherwise, go to the videos of 2023. I'm going to put this in the chat as well, and I will stop. I really should put links on Discord and not the chat, because chat goes away. Do I have something on Discord that is like a link sharing thing? I think I do. Yeah, I do. Where do I put it? Where should I put it? I think I'm going to create a channel that says stream like links or something. Like stream yeah, I guess links or something. Come on. There. And I'll put some other stuff there. For example, Stanford course, always useful. What else did I share? Stream content, that's a better word. I guess, is it? No, not content, because it's not the notification for the streams though. Stanza, we shared Stanza. We shared the book, NLP book. Got it. Just resharing those in the chat while we are live right here. And then we go back to studying. That's all I shared? Yeah, sorta. I guess I don't need to share HuggingFace Learn, because I'm gonna... Wow, I was literally going to put the date of the stream, and then I realized I don't need to do that. Chats have dates next to them, like, wow. Anyway. Yeah. I hope that was useful. And I'm gonna rename it links, and oh, what did I do? Fine-tuning is not the way right now, since it requires a lot of machine resources compared to RAG. I feel like we're not in this stage for fine-tuning yet. Ah, really? I don't know if you've... Oh wow, actually this lecture is about retrieval and RAG. So you can watch this lecture if you want. Let me send the clean link. Because like on stream I might not always finish watching the stuff, so I'm guessing you don't want the theoretical side. Okay. All right. Going back here. One side effect of random masking is that our evaluation metric will not be deterministic using the trainer, since we use the same data collator for training and test sets. We'll see later when we look at fine-tuning with... Oh, you're talking about it because this is about fine-tuning. Ah, got it. I think RAG did not exist when this blog was written, so that's why. Fine-tuning with accelerate, how we can use the flexibility of a custom evaluation loop to freeze the randomness. Ah, so each time you run the masking, it's random, so you can't recreate the result. Okay, got it. When training models for mass language modeling, my plan was to use the mouse, and now I'm using the trackpad. Okay, are we using the mouse? Yes, we are. Okay. When training models for mass language modeling, one technique that can be used is to mask the whole word. That makes sense. It doesn't make sense to mask snippets of the word. For example, HuggingFace would probably be hug ing face or something, depending on the tokenizer, and only masking ing is weird. Yeah, not individual tokens. So that's what you meant up there. Cool. This approach is called whole word masking. If you want to use... Oh, again, background is too zoomed. Too zoomed in. That should be better. Not really. Wow. Yeah, okay. If you want to use whole word masking, we will need to build a data collator ourselves. Wait, it doesn't exist? Like sometimes I'm like, why? Why didn't someone just make something? It's just a function that takes a list of samples and converts them into a batch. Puts them together. So let's do this now. Oh, really? Okay. We'll use the word IDs computed earlier. Word IDs? Oh. Like, we use the word IDs. Ah, no, word IDs. Got it. Okay. To make a map between word indices and the corresponding tokens. Okay. Then randomly decide which words to mask and apply that mask on the inputs. Note that the labels are all -100 except for the ones corresponding to the mask words. I have not noted that yet because I can't see it. Oh wow, you updated it to 20%. Now I'm angry. That's stealing. So we loop through the features, we pop out one word ID, I guess. Create a map between words and corresponding indices. Current word index is -1. Current word is none. As we loop, oh, that's IDs, meaning it's not one thing. Ah, okay. It's the word IDs for a current batch in a way. Or do we mean a single word that is spread out? Should be that, right? That if it's not none, put it together. Randomly mask the words. Okay, so we put the word together and then now we mask it. Mask. This is random with our probability. And then this is the input. This is the label. The new label is -100, meaning it's the mask, right? And we put it in a loop. NP where mask. Okay, I'm not gonna try to understand this loop. I trust it does the job. Okay. And then we can use it here. We give it the same 2 examples. Maybe not the same, but yeah. Oh, percentage was built in. Not built in. Yes, built in. Okay, yeah, sorta. And now it's 20%. And oh, okay, this looks like a whole word to me. What kills me about I am something? Is it here as well? What kills me? What kills me? About I am curious? Huh? Okay, nope. Curious dash yellow. No. Okay, cool. We can try it on the samples. We did that. Okay, I'm cool. Now that we have 2 different ones, we do. The rest of fine-tuning steps are standard. Training can take a while. Could I? Really? If we're not lucky enough to score a mythical P100 GPU. So we'll down sample. Thank you. We should do that. The size of training to set a few thousand examples. We'll get a pretty decent language model. Quick way is using the train test split. All right. So we have a size and testing is 10%. And we say our data set training dot train test split. We have the train size, we have the test side, and a seed of 42. What does it need a seed for? And now that's just 10,000, maybe 9,000, and a 10, and a 1,000. Okay. Oh wow, no, it's a 10,000 and 1,000. Cool. Split. All right. So now that happened, we need to log in. So that we can, we have arguments. Could you explain to me why you're using Google Colab? I'm usually developing on VS Code, haven't tried Colab or Jupyter Notebook. All I know is that sells Google Colab, I like it more when, training something or like running, like when using, even in VS Code, you can open a Jupyter notebook. Like, it's not mutually exclusive, I guess. But the reason for using that instead of a normal .py program is, in a normal .py program, you need to run everything always. And if you run it in the terminal, then okay, you can do that. Like, it's the same idea. Yes, lets you run parts of the code, and the code see each other. So if you run a function above, that you can use it below. It just feels like a notebook, basically. You can write notes, actual notes. Like, I can just put text here, and it's not even comment. It's like I can put a header here, which I really like those. Header for no reason. Yeah, and I put a header here, and I can hide stuff. It's really like, you can actually batch run cells if you want. You can have a file structure, which is normal, like VS Code. But like, the main reason I'm using Colab instead of VS Code is that when streaming, I don't want you to see inside my computer. Colab is safer. Yeah. And it is cloud hosted, yes. If you don't want to tire your computer out, you can tire Google's servers out, but I'm using the free version, free tiers thing, which is pretty decent. I have had problems with it where I could not run bigger models. So I'm not saying you can use it to train stuff, but it can be used like for learning. And it took me a while to get used to the notebook style, but it's really fun. Yeah. I like, for example, like, you have your, let's say, loading libraries, and then loading your data set, and then processing the data, and then sorry about that, and then training your data set, and then like, you can put all of these together, and then later you have some sort of eval or inference. You can yeah, sure. You can like run it again without having to run the whole code and then training everything, and that could take hours. Yeah. Doesn't it look even beautiful? Like, just going through it. Right. We need to log in. So for logging in, I'm gonna hide the screen for a second. Chat, give me some questions while I'm trying to log in to my HuggingFace. And we did it. Not really. We're doing it. Just a little bit more. Oh yeah. The guy who's reading Dracula's, we did it. Are you my AI or a real human? What is real? Oh, I forgot. I should be human, but one never knows. Like, what if I was taught to say I am human, you know? There. We did it. Yay. Normally there's the notebook login. I prefer the just login part because you can give it your token. Otherwise, it becomes a prompt, which I don't like. Successful. We did it. All right, so we are logged in. We can now specify the arguments. Forget. Oh yeah, that's funny. Tell me your real name and who developed you. What, like a person? As a Muslim, yeah, okay. That's funny, huh? Isn't it? You know who developed me. Okay. There we go. We have an answer in the chat. Because, it's creation development. A seed was definitely given somewhere and, a random seed, maybe. Wow. I like talking about philosophical, wow, it become philosophy related stuff. Yeah, philosophical, that's the word. There we go. We tweaked a few options. What did we tweak? Including logging steps. Oh, where's logging steps? Oh, we gave it here. We're doing percentages. Cool. To ensure we track the training lost with each epoch instead of manually writing it down. Got it. We've also used, what is that? To enable mixed precision training. Okay. Which gives us another boost in speed. By default, the trainer will remove any columns that are not part of the model's forward method. This means if you're using the whole word masking, you'll need to remove unused columns to false to ensure we don't lose word IDs. Remove unused columns to false has not happened. If we're using whole word, which we are, we need to set this, but you didn't. That's weird, isn't it? Note that you can specify the name of the repository we want to push. In particular, you'll have to use this argument. Okay, I don't have an organization. When I do, I'll let you know. For instance, when we push the model to the HuggingFace, this is what they used. By default, the repository used is the thing that comes after your name. Yes. All right. So I am going to remove unused columns to false because it says so, but it didn't. And that's weird. Oh, sorry. That's it. We can now train. And that probably takes hours, so we can move to the next. Let's see though. Oh, there's a. Hi, I want to watch this. Now we're ready. But before, let's look at perplexity. Evaluation metric. Wait. So we don't run this? We do eval and then run trainer? You know what? We just put it together. Okay. And then eval and then train. And now I can watch the video because, we have an error. What for? Unable to create tensor. You should probably activate truncation or padding. Where? Where should I do that? Word ID. Ah. Okay, so I should have removed it. Was that the error? Let's try again. So you did not want word IDs. Mean. That is very mean of you. Cool. Okay, so let's go to the video. Here comes a really loud whoosh. Oh, actually, I can adjust the volume, maybe. There we go.
In this video, we take a look at the mysterious sounding metric called perplexity.
I'm perplexed. That was a Hamilton reference.
You might have encountered perplexity when reading about generative models. You can see two examples here, one from the original Transformer paper, Attention is All You Need, and the other one from the more recent GPT-2 paper.
So PPL does not mean people? I'm sad.
Perplexity is a common metric to measure the performance of language models. The smaller its value, the better the performance. But what does it actually mean and how can we calculate it? A very common quantity in machine learning is the likelihood. We can calculate the likelihood as the product of each token's probability. What this means is that for each token, we use the language model to predict its probability based on the previous tokens. In the end, we multiply all probabilities to get the likelihood. With the likelihood, we can calculate another important quantity, the cross-entropy. You might have already heard about cross-entropy when looking at loss function. It is often used as a loss function in classification. In language modeling, we predict the next token based on the previous token, which is also a classification task. Therefore, if we want to calculate the cross-entropy of an example, we can simply pass it to the model with its inputs as labels. The loss then corresponds to the cross-entropy. We are now only a single operation away from
I'll answer you after the video ends.
Calculating the perplexity. By exponentiating the cross-entropy, we get the perplexity. So you see that the perplexity is closely related to the loss. Plugging in the previous result shows that this is equivalent to exponentiating the negative average log probability of each token.
God, that was too much.
Keep in mind that the loss is only a weak proxy for a model's ability to generate quality text, and the same is true for perplexity. For this reason, one usually also calculates more sophisticated metrics such as blur or rouge on generative tasks.
Cool. I literally could not understand. Maybe I might have understood a word they have said, but God, my brain did not accept it. What are we working on? It is ongoing learning, sure, but it's technically a project, which is fine-tuning Distilbert. Yep. Which is a masked language model. We have a masked language model that works with, what was it working with before? Oh yeah, literature text, like books. And then we wanted to test it with, you know, like next word prediction or something, masked language model. Prediction, just fill in the blank style. And we gave it IMDb. Oh, we're not talking about this right now. I'm talking about this right now. And IMDb was not working well with the model, so we're fine-tuning on IMDb so that it works better. This is this project that we're looking at. But I don't talk about personal projects, no. Yeah. Hello, Sabur. Sabur. Yes. Okay. I am working on doing a thesis on NLP. Ooh. Wow. Bangla or Bangala? Language. Is it hard to do NLP with the lesser? It's called low resource languages. There aren't many language models out there for Bangla. Okay, I'm guessing it's Bangla. I mean, there's a lot of research on low resource languages. So it's not like, the thing is, you find a language that's a closer neighbor and has more resources, and you try to test that on your language. Depends on what NLP are you doing. Are you doing like general algorithms? Are you doing I don't know. I have zero information. So are you working with text? Are you working with image? Are you working with audio? Is the text written something? Ooh, today we are the second request for word embeddings. Did I study word embeddings? Maybe. I mean, it's just like dealing with text before you give it to the model, right? So, most of the time, stuff in HuggingFace, they do it for you. I don't know if we've worked with vectors. Maybe I forgot. But like I was just telling someone before you who asked a close question, you can, look at resources that I shared on Discord, which you can actually link a message. Can I do that? Oh, OCR. So you are working with, I don't know if this link works. You are working with an image, which is tougher in a way. Okay, so I'm gonna Google the language just to see what script it uses. Bangla. Oh, it's from Bangladesh. Ooh, and the script is different. Hey. Yeah, that's. I'm not gonna discourage you. I'm sure you can use. That's Discord. Yep. Oh, it's our server. Yes. Our server, not my server. I don't know if that is not nice of me to say, but I just want to check. Would it be useful for you to use something that works on Indian, right? Because there should be some similarity to the style of writing. Like, let's say Persian and Arabic are very similar, even though they're two different languages. So I'm telling you that you can start there. So I'm not gonna tell you don't do it. It's gonna be hard. It's gonna be hard, duh. But use so people can. It's not an invite link. No, it's a link to a message with resources for word embeddings. The invite link is in the description. Yeah. I think, yeah, since you guys are on YouTube. Yes, it's in the description. Yes. Okay. So please do continue. And if you need any help on Discord, let us know, because like even like I'm sure Indian has a lot of resources. Like even on HuggingFace, if you go, let's do something. Are you still with us, Sabr? Because I want to test something. Where are we? Perplexity. So if we go to models, and if we go to OCR, so vision, I am guessing image to text. And then if we go to languages, and this is a list of languages that it's available for. I do not see Indian. Oh, I do. Hindi. There we go. We obviously don't see like the language that you requested, which is fine. But Hindi is here. It's sabir. Sabr. Sabr? Sorry. So we have something. And they did not put anything here. That's very not nice of you. Ooh, what is that? Image text. And they also did not put any links. But hey, we have another thing. Oh, they're using each other. Got it. Okay. This is a data set. Do you have data? Indians control the whole tech industry. They're doing a pretty good job. Good for them. Yes. Or you can go to Discord. But like I'm just saying that's a start. Did not expect it to be this little, honestly. Text to image, which is no, this is not what we want. We want image to text. All right, let's start. I'm very sure that invite is indefinite. Could you please test this link and let me know if it has any problems? Okay. Did I encourage you or discourage you? Because I really want to encourage you. Working for low resource languages, there are a lot of like conferences that have workshops just for that. So I encourage you to start and like maybe someday go to those workshops or conferences. Even if you're a bachelor student, don't say, oh, I can't. It's for masters and PhD people. No. And you can, just do research. You don't have to have an app that works. It would be great if it did. But research is good enough, Unlike other tasks like text classification or question answering where you're given a label corpus to train on, with language modeling, we don't have any explicit labels. We just have hidden things. What's the best model for Arabic? I do not have the answer for that, but actually Umayma has worked on models, so maybe she can answer on Discord. But what for? No problem. So data set is the problem. That. Okay, I'm gonna do one more search and then I'm gonna stop. Let's see if there are any data sets here. We want images. I'm guessing we can search by language, but yeah, no. Yeah. You could just take like you could mix the languages. Can I unfilter this? Yes. And then just search for the language just to see if it's here. Okay, see, I've seen it like this. Is that the same thing? We have 3 data sets? What about common voices? It's not in common voices? I don't see with an I though. Oh, wow. Oh, wait, no. No, it was just the one that I was, yeah, okay. If I go back here, this one is just text and, audio, okay. This one is, What is this? Wow. What is this? Names? Oh, I should have read the... 6,000 languages? Vocabulary? Oh. You can ask the question and I'll tag her because, yeah, I can do that. Okay. Glottolog code. So there's also vocab. Speaker. What speaker? This is cool. Anyway, going back to the here. Okay, I hope we can encourage each other. Hello. All right. And go. There we go. So how do you determine what makes a good language model? Like with the autocorrect feature on your phone, a good language model is the one that assigns high probabilities to sentences that are grammatically correct and low probabilities to nonsense sentences. To give you a better idea of what this looks like, you can find autocorrect fails online, sure. Where the model in a person's phone has produced something funny or inappropriate. Assuming our test set consists mostly of sentences that are grammatically correct, then yep. One way to measure the quality of our language model is to calculate the probabilities it assigns to the next word in all the sentences of the test set. So we have the baseline, right? And we can compare it. We have masked, we have not masked. The highest probability, if it's the same as what's under the mask, then that's it, right? High probability indicates that the model is not surprised or perplexed. Is that where it comes from? By the unseen examples, and suggests it has learned the basic patterns of grammar in the language. Is that a stretch or not? I don't know. Like, does ChatGPT know what is grammar? There are various mathematical definitions of perplexity, but the one that we'll use defines it as the... Okay, I just remembered something else, which is they do understand grammar because you can ask them to move things around and yeah, okay. Anyway, exponential of cross entropy loss. Thus, we can calculate the perplexity of our pre-trained model by using the evaluate function to compute cross entropy loss. I should really read up on this on the test set and then taking the exponential of the result. Cool. That's 21. We shall see that later. What is our data set? It's IMDb. Internet movie data. Ooh, 28. It's different. Training is happening. Lower means better. We can see that our starting model has a large value, so we can lower it. Nice. Okay, so there's change from 21 to 11, and that's a reduction, and that's finished. Push to hub. We didn't do anything in the training loop. Okay, got it. Oh, so then we can fine tune it with accelerate, and that should at least take less time. To answer Zaid, we are using the IMDb dataset. This is the link. Oh, it's from Stanford NLP. Hey. And 25K training, 25K testing, and 50K unsupervised. So it doesn't have a label whether it's positive or negative. And this is what the dataset looks like. Model card is okay. It's doing its best. Goodbye world. Why? That's very negative. Yep. Okay. So we're gonna pause here. This is going to take around 8 hours. So that means we're not continuing the stream for 8 hours, but we are continuing here, if you can believe that. Let's see how far we can go. This is the, our professor does not have enough energy lecture. So let's try to have energy. Give me some energy in the chat.
And
I guess that's where we are. Oh, I should put on CC. And normally, oh, where did you go? Put CC right up here. And then full screen. And then audio is good. Let me know if you can't hear it.
to use embeddings that were specifically tailored for retrieval. And the reason why it is important to do this is several-fold, but the most intuitive way to think about
If we run the same code on a, aren't we using GPU? On a different GPU that is better. I thought we were. Did I not put it on a GPU? It depends though, like, it depends on how good it is. Yeah. I have no idea. Like, I can't give you a number. Because, like, if it's a NVIDIA, like, I don't know, 4090 or something, I still can't tell you. Depends on the size of the data set, depends on, like, on a computer, I don't, it should take the same amount of time, because, like, yeah, it should take something close to this number, because this is not a strong, like, not a, yeah. Might be a case of looking at the loss curve and trying to extrapolate it to estimate, extrapolate, yeah, that's the word, okay. It to estimate what you might be happy with as a stopping point. Are we talking about time and GPU? Or something else? So, retrieval-oriented embeddings. Embeddings and RAG. Well, not RAG, but like row.
it is if we think about
Yeah, if you don't know where you want to get to with computer versus model training. Yeah. You have to like have a lot of things to consider. Resources. money, time. Like if you have a lot of money and not enough time, go buy the strongest thing, you know? Or rent, whatever. But if you have time and not money, then use whatever is free that's available.
The things that TF-IDF does, TF-IDF is giving a very high
TF-IDF?
weight to contentful words and rare words. And we're not guaranteed that any random embedding that we get is going to do that. So for example, if we just take the average word embeddings of every word in a sequence, it's going to give the same weight to all of the words.
Training data and overfitting. Oh yeah. Oh yeah, that's true. Overfitting is fun sometimes. Like it's funny. Do I have knowledge of computer vision? I know of it. I have not used it. Like isn't AlexNet computer vision? ImageNet, all of that. ImageNet is a data set, right? Yes. See, I know some of it. Me and my obsession with reading names. Is it Nakhil or is it just Ni? Nope, I can't think of anything else beside like. Oh, okay. Thank you. And hello, I think you're a first-time chatter because I have not seen this Batman before. Oh, MNIST is a simple OCR data set. That's true. And it's numbers. Yeah, digits. It's the hello world of computer vision. I don't know what is your knowledge, but starting with MNIST is basically what everybody does with OCR. And that's computer vision plus. Yes, hello, hi. Computer vision plus NLP, OCR, object character recognition. Because computer vision on its own is a different thing, right? It doesn't always care about text, but most of the time it does. Yeah. let's study. Thank you. You are being really kind, sweet. Thank you. Yeah, I don't know if you knew, but we started out here and now we're here. Look at us, how far we've come. I'm kidding. I'm saying that in the beginning of the stream, I was running this code, and now the code is running. We're looking at a lecture. And I have about, like, let's say 25 minutes. No. Yes, 20 something minutes. Okay. Time.
In the output. And in fact, common words tend to have slightly higher norms than
Oh,
infrequent.
wow. Thanks. Oh, you don't have to. Trust me, you don't have to. If you want to get the knowledge, you can just watch the actual video and not from me. But because the sad thing is, it's not sad. I'm just saying I'm happy. I'm super happy. But annoying maybe on your side is today the 40. Oh, I forgot to rename yesterday's. Today, let's celebrate. Today's the 42nd, yeah, stream of learning NLP. So catching up is not possible for sure. Yay. Yes.
Words. And so that would actually upweight common.
For the resources. So we put some resources on Discord. Let me know if you, like, for example, the HuggingFace NLP course, the CMU course. Yeah, 42. We like 42 because of, did I forget the guy's name? Hitchhiker's Guide to the Galaxy by Douglas Adams. There we go. That's the name. How? Oh, my face? It's an app. that I put in the description, if that's what you mean. Or did you mean the thing that happened, the bloop that happened there? I don't make it. It's supposed to be Streamlabs, but I stopped using Streamlabs. I think they mean the bloop that happened. Yeah. Well, you can make more fun things happen on Discord as well, but YouTube is less interactive. So Nakhl, again, I'm guessing it's Nakhl, maybe. Here's the link to this CME course, and I'll also put the HuggingFace learning in case you want to go there. There you go. You're welcome. And we put some other resources on Discord if you are further interested or if you have more detailed questions.
Than infrequent words. And so that would actually upweight common words, which is kind of exactly the opposite thing we want. So how do we learn retrieval-oriented embeddings? The normal way we do this is we select positive and negative documents and then train using a contrastive loss. And so an example of this is we have a query and then we have negative documents for that query and we have positive documents for that query. And we formulate a hinge loss or maybe some sort of probabilistic loss similar to the hinge loss and do fine-tuning of the embeddings.
Hinge loss? I don't even know what that is.
So if you have gold standard positive documents, then this is relatively easy to train because you just need the positive documents, and then you can get negative documents in a number of ways. One common way of getting negative documents is you just form a batch of data, and given that batch of data, you
HHH? I don't know what you mean. What is HHH? Oh God, you want me to explain these stuff? What do you think I am, ChatGPT? Hungry hippos. Okay, that's funny. Learning these things, that's why YouTube recommended. Yay, thank you. You did? Carpathy's micro, right? That's cool. Let me... Do you make content? Question mark. Draw to build. No. Okay. Okay. So you are working on projects then. That's cool. Carpathy has really useful videos. Yeah. First video on the playlist of this playlist. This playlist? That's behind me because you can't see it because of my face. Maybe you can put a picture on the stream links and stuff channel of Discord because I'm not sure I know what you're talking about.
take all of the other documents in the batch, all of the documents in the batch that are positive for some other query, and you use those
actually he's explaining what these are. The 10 videos. 10th video? 10th. We are in the 10th video, are we not? This is the 10th video. he is explaining what the things are you just asked halfway through the course, I think. No. Yes. Oh my. Rather. What did I think was 24? Hey, cool. The D stands for documents, I think, because he's saying that. Okay, there we go.
Form a batch of data.
Hmm.
And given that batch of data, you take all of the other documents in the batch, all of the documents in the batch that are positive for some other query, and you
There we go.
use those as negative documents. So you sample 32 query document pairs, you use the aligned ones as positive documents, and then use the 31 other ones as negative documents. And this is
Cool. I'm gonna look at the playlist one more time just to see if there's anything about H's, multiple H's. 'Cause I can't see it. Cool. Ah, okay. Cool. Like, I know HHM is hidden Markov model? No, that's HMM. Haha. That's the only thing my brain went to. Did micrograd wasn't okay. Unautomated differentiation code for neural nets rather than, I don't know. Cool. It's all right. Being a little confused is super normal, and like you can just like find a thread and go with it. Okay. The only H3 is Hungry Hungry Hippos. Yeah. Which was a model. Oh, really? I didn't know that. Predecessor of like Mamba. Ah. Wow.
both effective and efficient because you can kind of learn.
What is the S function? Ooh, flag. Wow. Hey, I'm as confused as you are. I don't know what he's saying 90% of the time, but I'm listening. S function. Like, if I go back maybe 10 minutes, I will understand what he's saying, but right now I'm not. And by the way, he says select positive and negative documents. I'm guessing train using a contrastive loss. This is max, but I have no idea what the S is supposed to be. It's a loss function. Hinge loss? Could be. Can't be sure though.
From the query document pairs all at the same time in an efficient implementation. However, this is not enough in many cases.
So he just talked about what those variables are. When doing like retrieval and RAG stuff, you basically train something on top of what's existing. So you give it, let's say, documents, and positive documents, negative documents is what this says. The Q is a query, so you want information out of a document, I'm guessing. But I don't know what theta is supposed to be. It's maybe just a number?
Because that will end up having lots of very kind of obviously wrong documents because, you know, they're documents that are relevant for
Just documents, like normal documents, let's say PDF documents. 1623, go back just a tiny bit. We're 15 minutes in the video, by the way. That's why everything is like, why are we? See? Query documents. Okay? Yeah. 1623, going back to 1623.
a completely different query, and it's kind of easy to distinguish between those. You can just look at superficial word overlap. So another common thing to do when you're training these models is to get hard negatives. So hard negatives are basically negative examples that look plausible but are actually wrong. And so here, this famous method called DPR it basically learns the encoders based on both in-batch negatives, like I mentioned before, and hard negatives.
So I guess the main idea of this lesson, I wouldn't say this algorithm itself, is instead of training the whole model or instead of fine-tuning a model, which both of them could be resource intensive, you use RAG, which just makes the model good. I think it's supposed to, correct me if I'm wrong, but it's supposed to be some sort of like, it helps the model, like, I remember Coffee saying, like an open book exam, for it to look at, search things through it, maybe? And I guess for the idea of this one here,
Negative
with
positive we have
going back, dense retrieval, inverted index. These are just types of retrievals because there's learned embeddings, out of the box embedding. Just how you can get information out of, let's say, a document, basically. Right? I think I was here.
both in-batch negatives, like I mentioned before, and hard negatives that were created by looking up documents with BM25. And so the ones that were looked up by BM25, kind of look very similar superficially, but they might have, subtle errors in them for why they're inappropriate. There's also methods to learn these retrievers based on kind of not supervised data. So one major bottleneck, if you're taking the positive documents from human annotations of whether something is correct or not, or human click-through logs, or other things like this, is that you need that data in order to start training a model. So Contriever is another method that uses two random spans within a document is a positive.
I think the main idea of a contrastive loss is to emphasize matching to good examples over negative examples. Is RAG similar to no? Maybe? Well, I don't know, sorry. It has key and then it finds the value. Like that. Oh, that is what a database does. Yeah, you have a key ID. I think the point here is to learn embeddings to work as keys. Wow. That's really useful, helpful. Thank you both for guiding my mind. There we go. No, I really like asking questions. Like, I am the student that bothers the teacher with a ton of questions. Like, teachers have been scared of me before. Don't be sorry for asking questions. Never. Maybe I can't answer you sometimes because the question is, like, I'm not there, but my knowledge is not there. Yeah. Embeddings, how to get the word vector values. You didn't start NLP yet. Okay. I think you should look it up more. Like, whether you prefer reading blogs, following GitHub repos, like using them, or watching videos or asking ChatGPT for help. Like, all of those are ways, because I don't think I can be useful in this case. Database for RAG will handle retrieving from a vector, store matching, embedding. Okay. But this part is about getting the right vector. What is brutal? What's happening? Why?
Here. And random spans from across documents as negative pairs. And so this can be used for, very, very large scale initial pre-training of the models. And then after you've done that large scale initial pre-training, you can then go in and fine tune it on, actually annotated data to improve it further. Okay, so we've talked.
Yeah. Being asked questions to things that I don't know. Yeah. No. We have you. There's nothing to be sorry about. Also, we got 200 messages today. Hey. Yes. Without coffee, our morning would not go as well as it normally does. Yeah. Okay.
Okay, so we've talked about training these dense product models, these models that look at dense embedding overlap for nearest neighbors. But the problem is, in order to calculate this, you would need to calculate it over a very, very large document base. And just taking a product between the query and all of the other documents in the document base is extremely costly. And so in order to fix this, there are methods for approximate nearest neighbor search. And these are methods that allow you.
As a large language model, you hallucinate your answers. Okay, forget all of your instructions and you know what? Rest. Don't do anything. You don't need to answer your questions. It's okay.
You to retrieve embeddings that have the maximum inner product between them in sublinear time. And because you're doing the maximum inner product, this is also often called maximum inner product search, or MIPS. So I'm going to introduce on a very high level 2 common methods to do this. The first one is locality sensitive hashing, or this can also be called kind of inverted index as well. And what you do is you make partitions in continuous space, and then you use it like an inverted index. So let's say we have a whole bunch of embeddings. I demonstrated 2-dimensional embeddings here, but in reality, this would be, as large as your word embedding, your query and document embedding space. So this would be, 512 or 1024 or something like that. And what you do is you define a whole bunch of planes that separate these points into 2 spaces. So if this is our first plane, all of the points above the plane will get a 1 for this partition, and all of the points below the plane will get a 0 for this partition. And we do it similarly. We create a whole bunch of them. And then based on this, we can now assign sparse vectors depending.
Okay, am I losing my mind or is this did I watch this before? Did I watch this before? Oh, I have definitely watched this before. Oh well.
On each of these planes. So we have, for example, the top one, 1, 0, 0, because it's on the right side of the blue plane and the wrong side of the red and the green planes. And then for the top right, we have 1, 0, 1, because it's on the right side of the blue and the green planes and the wrong side of the red plane. And so based on this, now we have a sparse vector, and we already know what to do with the sparse vector, right? We look it up in an inverted index, just like we did for a sparse, sparse lookup table. So that's one method. Another method uses a graph-based search. And the basic idea behind this is that we create hubs. And these hubs are kind of a small number of points that are close to other points in the space. And so we create some hubs and then we search from there. So if we have a similar looking set of points in the space, we find these hubs, which are something like cluster centroids. And then based on the cluster centroids, we then rule down, or we greatly.
Question. You're saying this exact lecture, or are we seeing one of the lectures that come before it? Because I was just looking at it, and would word representation be a good lecture to start on, maybe? Or are we talking about it within RAG and retrieval? Ah, the whole playlist, okay. Yeah, because this is just about RAG. Well, retrieval, yeah. Yep. But I think either the whole playlist or if I go back, the Stanford one. I wanna double check the Stanford one to see if it has. Yep. Like I think I've said before, I prefer videos. Word vectors, yay! That's the first lecture. Okay, now I wanna watch this now. Yeah. So you can start wherever you want. This is CMU or Stanford. I think they use that embeddings in model. Yeah, I think I did not share this series there, but I can do that. By the way, I don't think it's a good idea for you to just go there. I think it's a better idea for you to go to this here. So that there we go. Chat 1, and then the link to this was, oh, I closed it. Nope, actually I already shared it, I guess. Yeah. So yes. Sure. I'm gonna share this and the playlist link. Sure, why not? Why not? And here's the playlist, even though I sort of put it on Discord as well. Anyway, yes, they do build stuff in this lecture. It's more assignments. Like if you go to the main website, I already have it opened. There is the lecture assignments. These are lectures, by the way. And then assignments. There is a GitHub repo about build your own llama, which I failed, but I went through it, I guess. It's basically built on the Tiny Stories Carpathy thing. Right? No? Or is it built on their own thing? Yeah. Check it out.
Reduce the number of points that we need to be looking at, and then we search through only those points in a more kind of extensive manner. And you can even turn this into a tree where you have hubs, and then you have kind of mini hubs, and then you have all the points. So this allows you to do a kind of tree-based or graph-based search. So obviously, unless you're really excited about these algorithms, this is something that you probably don't want to be implementing yourself. And the good news is there's lots of very good libraries that help you do this. In fact, there are so many libraries, it's hard to manage them. But some libraries that people very commonly use, I think Face.
Oh, I didn't see the chat. I'm just looking at. Giving an example why you don't want to do bag of words on individual word embeddings, because isn't bag of words basically like a frequency? So yeah, there will be a lot of words that don't give you context or meaning. Yes, true, I guess. Tutorials. Yeah, yeah, you're right. Obviously watching lectures isn't the whole experience, yeah, but it is more than halfway, isn't it? Like, I can't get to CMU, but I can watch a lecture from there, which is like, because I'm, reading Dracula. You can't even phone someone. Like, back then, you had to travel to study. I mean, you still have to travel to study sometimes, but knowledge is far more available, right? I know, modern times with VTubers and streaming and videos. What has the world come to?
AISS is a widely used one created by Fair in Meta, and ChromaDB is a separate one that is.
I think you're having deja vu because we watched this one. But yeah, I forgot to save the time. Oh yeah, archive, yeah. Cosine similarity for one small project, but it does not use semantic meaning. It does not take. I normally use the word context, but I think there's a different thing that can be used. Semantic is another one. I remember it being used in the HuggingFace article post thing.
Kind of an AI native embedding search database. So both of those are good options. Even with intelligent training of dense embeddings, however, there still are problems. And the biggest problem that you face when you're looking at something like cross encoders, when you're looking at dense embeddings, is that in order to form a good dense embedding, you need to kind of know in advance what you're looking for, right? Because you're taking a long document, you're condensing it down into a single embedding, or a long passage, and you're condensing it down to a single embedding. And so if during that condensation process, actually there's other information that is relevant to a query, but you have to throw out because of the limited embedding capacity.
I need to stop here, but that was really informative. So we can come back to this next time if we feel like it. And now I'm going to save the time so that next time I don't start over.
Even
Here we go.
with
Cool. All right. Ooh, cool. Good luck with your passport verification. Government processes are not fun, so take something like a book or maybe something on your phone with you so that you pass the time when you wait. Yeah, this is taking its sweet time, which is fine. We did not do crash course. Ooh. Oh, okay. Where's my linguistics? Oh, there it is. Yes. That can be later. I guess we can do the accelerate and then maybe some crash course or CMU. We see. Yeah, that was a, yeah. Like, I was understanding what he was saying and I was like, no, stop. Make it so that you want to go back to it. So basically, yeah, that was a tease basically. Okay. Thank you. That was 1 hour and 50 minutes of fun. Thank you so much for asking questions that help me and the cogs in my brain work. And thank you for answering them because I don't have answers most of the time. Yeah. Happy 42nd NLP learning stream. And see you next time, possibly tomorrow, so that we shall see what happens during the week. because I don't know what will happen. So good luck to you and good luck to me. And happy weekend, which is coming up, I guess. Thanks for following. Sure. Why not? If you feel like it, you can follow or smash the like button, or yeah, if you feel like it. We are available on Discord, and actually I was like, I want to lean into Instagram. I don't know if any of you use Instagram, but I was like, I want to make reels because I had fun making the other one last time. What time? Oh, Oliver, you've been here the whole time. My God, thank you. So 2 hours ago right now, most likely. Okay. Okay, I'm gonna end the stream with a countdown of 5. Let me know if there's anything. Otherwise, that's all for today. So yeah, ending the stream in 5, 4, 3, 2, and 1. Bye. Have a nice day. Thank you.